Good morning, everybody. Miss Makano here, and today I want to walk you through this plate tectonics PhET lab. This is an 11-point summative, and let's get into it. You have a bunch of resources posted right at the top that you need to watch and read before completing this lab. There will be questions that you might not be able to answer without reading the resource linked here. So the first thing you're going to do is access the PhET activity. Now, this is a little bit tricky because unlike other PhET activities and labs that we've done in the past, this one you cannot do on your Chromebook. So you need a Windows-based computer to do it. I will distribute some in class, or if you have your own, then definitely feel free to use that. All right, once you're on a Windows computer, you're going to click PhET activity. It's going to bring you to a window that looks like this. And what you're going to have to do is download this file. So you're going to click download. It's going to download it for you right here, left-hand corner. You're going to click on that. And that should bring up a file just like this. It might give you a window that says to accept and continue, something like that. If it does bring up that window for you, make sure you click yes on that. And then it should put you at your screen, which should look like this, okay? Once you are here, you're going to continue with following the instructions in your lab report step by step. So part one, and this is how you're going to run all of these things. It asks you to begin with the crust tab. So you're going to notice that you have a crust tab right here and a plate motion tab. So you're going to start with the crust right there at the top, and it's asking you to use the tools in the lower left hand corner. So notice that there are a bunch of tools here. You want to make sure when you're working on this first part of the lab that you have both, and show labels should be clicked for you. All right. And then it's asking you to basically have a look and compare thickness, density, and temperature for oceanic and continental crust. So let's have a look at that. So when you first come to, let me click those both and show labels. So when you're on this window, you could see the labels. So we got oceanic crust over here. We have oceanic crust over here because it's in blue. That's how I know. And we got continental crust in green. The first part of the assignment is asking you to measure the size of it. So you can use your ruler to measure how thick is the continental oceanic crust over here, over here. How thick is the continental crust? You're going to measure that. You can use the thermometer to get an idea of their temperatures, which one is higher, which one is lower. And you can use this density meter right here to give you an idea of the density. So here's the density of oceanic, and continental, okay? Once you do this, you go, let's see, let me go back to the assignment. So you're going to complete your observations in this table. What are you noticing about the thickness? Which one is thicker, oceanic or continental? How about density? Which one is more dense, temperature, and so on? You're going to complete this information. Then you are asked, which property do you think causes the continental crust to have a higher elevation? So elevation meaning you can see that the continental crust is basically sticking up above the oceanic crust. So why is that? Think about the properties such as density. What happens as things get more or less dense? You should go back to what we studied in, I believe it was Unit 2 under density. We studied what happens when an object is more dense than water, tends to sink. When an object is less dense than water, it tends to rise up, okay? So using that, you can answer this question. It is then asking you question 3, 4, and 5. Basically are asking you to go ahead and adjust different things. So you can adjust the temperature of this plate, and you can see that as you adjust, it changes from blue, which is oceanic crust, to green, which is continental crust. Same thing with the composition. You can see, let's look at this composition a little bit in more detail. So composition, you can see that if I put more iron, that makes it more dense. You can see how it sinks down below the continental. If I make more silica be part of this slab over here, more silica would make it less dense, and you can see how it rises up, okay? So this composition, basically, as you change that, you're basically changing the density of the crust. You're making it more iron makes it more dense, more silica makes it less dense. And depending on that, you can see how it's going up and down. So you're going to explore that as part of your questions. And you're also going to explore modifying, changing the thickness and what happens to that, okay? So those are basically questions 3, 4, and 5. As well as 6, you're going to describe in question 6 which type of crust tends to be thicker or thinner, the continental or the oceanic. You're going to fill in this table. And then we're going to go to part 2. So part 2, you are now going to go to the tab that says plate motion. So we're switching over to this tab over here. And basically what you're going to end up doing for this is you are asked to make a bunch of different combinations and see what happens. So let me show you what I mean by that. So right here in the right hand corner, you can see you can select continental, oceanic, or old oceanic, young, and old oceanic crust, okay? So let's say for the first part, I believe it's asking you to click, let's see, well, I actually want to show you a kind of harder one. So let's say 2 old oceanic crusts. It's asking you for question number 8. The other questions are very similar. So I'm going to take old crust over here and old oceanic crust over here. And I'm going to show, let me see, are they asking you to, no, I think we're good. All right, so now that we got the old oceanic crust on both sides, what you want to do is go up here in the left-hand corner, and you're going to do this for every question in part 2. You want to be in automatic mode, okay? When you're in automatic mode, it's going to give you some selections over here. So you can select if you want to have a divergent boundary or a transform boundary. So let's kind of explore that. So right now I have divergent boundary. Those red arrows are selected. Let's see what happens. So divergent boundary, as you guys know from what I talked in class, it means that the 2 slabs are pulling apart from each other, as you can see in the simulation. You can see that's happening, okay? So you're going to have questions about that. You're going to observe what happens. I believe the assignment is asking you to draw a diagram. So you would draw basically a diagram. And it's also asking you what kind of features do you have happening. So right here, there's a specific name for that. There's a special name for what is happening right here. In this case, that name would be a mid-ocean ridge, okay? But for different situations, there are different features, and that's when you need to do your research using that link that I gave you at the beginning of the assignment. You can also run this in manual mode if you want to run it yourself. So you get these joysticks over here, and you basically just hold them down. And let me just reset it because I think, let me just reset that. Okay, so with the joysticks, you can just pull them down, and it basically does the same thing as the automatic mode, but you gotta just hold them there. Okay, the same thing. All right, let's see what else I needed to give you guys. So 8, 9, 10 is basically the same things, but just for different situations. Let's do one more together. So let me reset, and let's instead put 2 continental crusts together, and let's see what happens. Instead, let's see what happens when we bring them together. So let's do a convergent boundary. The green arrows are selected. Convergent, meaning they're coming together. And let's run that and see what happens. So watch as they're running together. You should see a special feature happening. So you can see a kind of something going on right here, and there's a question in the assignment asking you what kind of feature is that? What is happening there? Okay, so you should either from your research or just by thinking about it, you should kind of get an idea, okay, what is this feature that's happening right here? Again, you could do the exact same thing and run it in manual mode if you prefer that. So just take the joystick and push it in the direction of the green arrows, and you can see those two slabs. They're basically coming together, pushing against each other, and as they do that, what happens? And finally, let's do one more. Let's do mix this time. Let's do a continental and an old oceanic crust, and let's see what happens. And as you notice, you only have one option here. You only have this option, same thing in automatic mode, of convergent, meaning coming together. So let's see what happens as we run that. So you can see the oceanic crust is moving under. It's sliding under. There's a special name for that. That is called subduction. That's something you need to know. So you can see it's sliding over under the continental crust. And as it's doing that, you can see these little bubbles. Basically what's happening is that this oceanic crust is more dense than the continental crust. It slides underneath it. It starts melting because of the heat from the inside of the earth. And as it's melting, you can see these little black smoking volcanoes forming on land. Okay? So this is an important concept that you guys need to be able to reason through it. Why is this happening? This is a convergent boundary, meaning the two plates are coming together. One is sliding under the other because it is more dense than the other. And as it's sliding, it melts, it forms these volcanoes, and there's another special feature right here that is called a trench. That is also really important feature associated with convergent boundaries. All right, finally, let's see, question 11 is asking you to analyze this diagram, which is of a divergent boundary, meaning they're moving apart. The plates are moving apart, as you can see. These are both oceanic crusts, and it's asking you which point A or B do you think is going to be the older rock, and why? Okay, so kind of think about that, watch the simulation, and go ahead and answer the question. Finally, question number 12, you're going to come up with your own scenarios now. You're going to create two different scenarios with different crusts that you haven't explored before, and you're going to analyze what happens with those scenarios and some new features. And question number 13 and question number 14, pretty self-evident. So go ahead and answer those. I hope this video was helpful for you, and I will see you guys in class.